Hey, what's up guys? I'm Theo Joe, and today I'm going to show you how you can get 1 million subscribers. This is exactly what I did to get as many subscribers as I have, and it's definitely something YouTube does not want you to know how to do. And no, of course, this doesn't involve buying subscribers or any of that nonsense. This is a real method, it's legit, and I'm going to go over it today. Basically, we're going to generate a special redemption code that we can put into YouTube that will give you higher priority in the algorithm, so your videos will always be at the top of all suggestions, whether it's search or suggested videos. And so as a result of this, YouTube will promote your channel until you reach the specified number of subscribers that you request. Now, that all might seem a bit complicated, but I'll walk you through it. It's actually very easy. Let me show you what I mean. The process is basically that we go to the Google Store, which will allow us to redeem certain codes, and then we put in this special code that we will calculate and is unique to your channel. Then you simply wait for the subscribers to roll in. You'll notice your videos getting way more views than subscribers, and of course, the more videos you have, the faster this will go. You can see that I just figured this out last month, and the redeemed code I entered actually shows up in my order history. Then, if you look at my channel stats for the same time, there is a huge spike in subscribers and views as a result of this. So all we have to do is calculate the code that is specific to your channel and then redeem it. It does involve a little bit of math, but it's pretty basic arithmetic. You shouldn't have any problem. I'll walk you through it. Before we do get started though, you'll need to write down some basic information about your channel so we can use that in the calculations. First, you'll need your channel ID. This is not your username, so don't mix that up. If you go on YouTube and click My Channel, your channel ID will appear in the URL as a long string of numbers and letters. Next, you'll want to write down the number of subscribers you want to get. From what I understand, the maximum is 1 million, so we'll just use that for this video. Finally, you need to write down your current number of subscribers, and don't worry if this number changes. As long as you had that number in the past day, it'll still work. And also for this video, I'm just going to use the number 500 because I already have over 1 million subscribers, so the calculation wouldn't work. So 500 will just be our example. So now that we have everything we need, let's go over to the table and I'll walk you through how to calculate this. Okay, so the first thing you'll do is write down your channel ID because the first step is to convert that channel ID into a number, and we can do this by assigning a value to each letter in order of the alphabet. So for example, we can do U is 21, C is 3, and so on, and if there's a number, you just put that number, and you can ignore any special characters like a dash. So I'll just go ahead and do that, but you can do it yourself. And like you can see, you want to string all the numbers together. You're not adding them, you're just creating a big long number. And the reason it's so long is because, of course, it has to be unique across all channels on YouTube. And we're going to call this whole number the UMRN, U-M-R-N, or Unique Mathematical Routing Number. And don't worry, because the most difficult part is now over. We have our UMRN, we have our sub number, which we can write down as number 500. That's the example we're using, and the sub goal is 1 million. We can write that as 10 to the 6th. And these are going to basically be the 3 function parameters that we're going to use in our calculation, so we can separate these out. Those are not going to change. Now the next step is you want to look at your UMRN and look at the last number that is greater than 2. In my case, the last number is 7, so we can write that down, x equals 7, we can call it x. But for example, if your last number is 1 or 2, you would go to the last number that isn't less than 3. So pretend my 7 wasn't here, the next one would be 3. Now you want to take that number and draw a regular polygon with the same number of sides as that. So I'm going to draw a septagon, but you might draw a triangle, for example, for 3, a square for 4, etc. It doesn't exactly have to be a work of art. I'm definitely no artist. And they might not look exactly correct, but you can see that there's different vertexes, and there are at least 7 sides. I guess you technically don't need to draw it out. You could just look up a picture, but it should make it easier to understand the next calculation. So now we need to calculate the area of our n-gon, assuming that each side is equal to the current sub number, in this case 500. So for example, this side is 500, and all of them are the same. And we know that the area of a septagon is the following formula. A equals 7 over 4, s squared cotangent 180 over 7, which is the same as 7/4 s squared tangent 180 over 7 to the negative 1. And remember that s is 500 here. So now we can just plug all that into the calculator, and of course you want to be in degree mode or else radian mode won't work. And also remember that you're only going to do this calculation if you have the same number as me. You're going to have to look up the area for your n-gon. It's not going to be the same necessarily. So we can type this in ourselves, 7 over 4, 500 squared times the tangent of 180 over 7 to the negative 1. And that gives us 908,478.111. And we could call this little a, and we can just keep it to about 5 significant figures. So it would be 9.0848 times 10 to the 5th, and that'll be the value we'll use later. So I would box this up so we can reference it easier, and then we can move on. Now for the next step, we're going to need to calculate the nth iteration of the Koch curve using this value a that we just calculated. And the number of iterations that we're going to use is equal to x, in my case 7 again. We're going to be using this number several times. First, of course, though, we're going to have to know the number of polygons in the Koch curve before we can, of course, calculate the area. So the formula for that will be Tn equals n minus 1 equals 3 times 4, n minus 1 equals 3/4 times 4 to the n. And then we'll need to use that with the area of the first iteration, which is an equals n minus 1 over 9 equals a0 over 9 to the n. Luckily, we can collapse these into a much simpler function. Otherwise, we would have to completely calculate manually each iteration 7 times, but we don't want to do that. That would take forever. So we're just going to collapse this into a much simpler function, and that would be n equals a to the 0, 1 plus 3/5, 1 minus 4/9. The n equals a0 over 5, 8 minus 3, 4/9, the n. And then for this, the a0 will just be our a that we just calculated. So a0 equals our a, and then we can go through and calculate that. So after plugging all that into the calculator, we will get an equals 1.4517 times 10 to the 6th. And again, you're going to want to keep this value at least to 5 significant digits. You can do more, but it might make it more complicated. And of course, we can box this up. We're going to use this again, and then we can move on. Next, I'm sure many of you already guessed, but we're going to be using the Mandelbrot set. I probably don't even have to write it down, but I will just in case for some of you. So of course that would be z n plus 1 equals z squared n plus c. And that is a 2. Now with this, we're just taking a point called z in a complex plane, where z1 is z squared plus c, and z2 is z1 squared plus c, and so on. And luckily, we don't have to do the entire fractal. We just have to calculate the first iteration, so it should be easy. And as you guessed it, we're going to assign c as our constant as 7, so c equals 7 equals our x. For z, however, that's actually a vector, so we're going to use the coordinates of our umrin and our subgoal. So our umrin we'll call u, and our g we can call g as goal. Now, I messed that up, but that means that z will be our coordinates u, comma g. So therefore, z1 equals u, comma g squared plus c. Of course, to square this, we're going to need to do the vector product, so we can just write that down. U cross g equals I, j, k matrix. So that would be u1, u2, u3, g1, g2, g3. I'm going to assume that you guys already know how to calculate this, so I'm just going to speed through it and write it down for those of you who maybe aren't sure. And I already did the calculation before, so you don't have to sit through it. The result is going to be 0 I hat plus 0 j hat, which makes sense because these are both x and y plane coordinates. When you do the cross product, the perpendicular vector is going to be in the z, so there's not going to be any extra y component, and the z is going to be 8.1384 times 10 to the 17th k hat. And we're still keeping this to 5 significant figures, and since these are 0, these just drop out, so pretty simple. So now we know the z value has a magnitude of the magnitude of this, and that's just going to be 8.1384 e to the 17th. And for c, it's still 7, but compared to something that's 10 to the 17th, that is so insignificant, so we can just completely ignore it. We're only using 5 significant figures, not 17. And that will be our z value. Alright, so that's not too bad. We can move on. There's just a couple more steps. Next, we want to take all this we've got and plug it into a third-order nonlinear partial differential equation. In this case, we're going to use the Korteweg de Vries equation, which I can write down as partial of u over partial of t equals 6u partial of u over partial of x minus third order partial of u regards to partial of x squared. Now you're probably wondering which functions we're going to be using in this partial differential equation as u, x, and t, for example, and that is a good question. And YouTube, to calculate subscribers, actually uses a couple formulas that we can take advantage of. First, we're going to use the Cantor function, should be pretty familiar. That would be c z y equals sum k equals 1 over infinity for b k zk. Alright. And then also the Riemann zeta function. So you're going to want to plug all that in and use our variables, and you will be left with the vector sum 9.001 e5 j hat plus 1.993 k hat plus I, that is an imaginary number, times c, the speed of light. So we can just box that up to use later, and I'm sure you're going to wonder about this imaginary number. Don't worry, that's going to drop out in the very next step, so there's no need to worry. So we can put that aside, and this should be the last piece of paper we're going to need. So finally, all we need to do is take all this and plug it into the Navier-Stokes equation, and specifically the Cauchy momentum equation, which of course is the partial regards to t of rho u plus gradient times rho u cross product u plus pi equals gradient tau plus rho g. Now, you were asking about this imaginary number in the previous equation, and to get rid of that, we need to convert the Navier-Stokes into 3D spherical coordinates. So that is pretty simple. It's going to be radius rho partial u tau regards to t plus vr partial ur over r plus u phi over r times partial ur over regards to phi plus uz partial ur over partial z minus u squared phi over r k. So now you should be able to see that when we replace these with all our vector differentials from the last one, most of this is going to drop out. In fact, this will drop out as well as everything except this first factor. So you didn't think I would make you do anything complicated, did you? So we just have to remember that r equals u tau over t. So when we go to plug this into the Umrin, we're going to get the result as a matrix. So let me quickly do that. And then when we go and take the determinant of this matrix, we'll get our special code. So let me calculate that out real quick. And this is what we will type into the Google Play Store and redeem our subscriber code. And that's all you have to do. We now have the code that we need, and you're done. Alright, so after you do those calculations, you will now have your special code that you can use to redeem. And as you can see, if we go to the Google Play Store and redeem it, it will now say success. You can also look in your order history. It should show up there so you know it worked. And now you just have to wait for the subscribers to roll in. You should see the subscriber count increase significantly over about the next month. And that's it. Now you can be the next big YouTube channel, and I bet there are a lot of big YouTube channels that did exactly this process but didn't want to share the secret, but now you can be one of them too. So if you guys did enjoy this video, be sure to give it a thumbs up so I know you liked it. And if you want to let us know down in the comment section, that'd be great. Did it work for you? How many subscribers have you been getting? And how many do you want? Also, if you want to keep watching, I've got some other videos on the right-hand side. You can just click those or look in the description for the same link, like if you're on a phone. And if you want to subscribe to this channel, I make new videos every week, so it should be worth it. I'm looking forward to hearing from you guys, so as usual, thanks for watching. I'll see you next time. Have a good one.